Okay, we're going to continue on with sum and difference identities in this session. We've got 2 sessions. We've done one of them already on sum and difference identities. Already done this, and we're working on this today, finishing it up, using them. Let's see how we could use them. Before I go on to the lesson, I want to pick up something I didn't do last time. I did do this 2 ways. Well, I didn't work them out, but there were 2 ways we could find the exact value of the tangent of 75 degrees. One would be with tangent sum, using this one here. The other would be using tangent difference, this one here. And still another one that I should have thought of is the tangent of 30 degrees plus 45 degrees. This could be found with the quotient identity, which would be sine of it. Now, for the quotient identity to work, it has to be the same angle, 30 plus 45. I should have thought of this too, because those were the ones we found in example 1 and example 2. So I actually have values for those. And what are those values? I've got this one here, square root of 6 plus square root of 2 divided by 4. That's sine. And for cosine, square root of 6 plus square root of 2. Oops, not plus. It's minus. Cosine was minus. Now, they're both the numerator and the denominator have 1/4 in them, don't they? Or think of it as being divided by 4. So those will cancel out as 1, and I'll have square root of 4 plus the square root of 2 over square root of 6 minus the square root of 2. And I could rationalize that if I wanted to. Okay? So that was a third way using the quotient identity. Verify identities using sum and difference identities. So we're going to verify this identity, the tangent of t plus pi over 2, or 90 degrees, equals negative cotangent t. So, how does that work? Well, first I'm going to use the quotient identity and re-express this as sine over cosine. Now, can I grab this from back here? I think I can. I'll take them all. This one, and this one, and this one. copy. We'll have them for our reference here. I won't need them all, but it's nice to have them handy. Okay, so this is a sum of angles. Sine, which is a sum, would be now sine of t times cosine of pi over 2 plus, remember with sine, if you're doing a sum, it's plus, the cosine of t times the sine of pi over 2. And in the denominator, we also have a sum. This, of course, is going to be subtracting. Remember, these signs are opposite. So cosine t times cosine pi over 2 minus the two sines. And we know that we have a value we can put in for this, for this, for this, and for this. Now we will not have a value for this one, this one, this one, or this one, because we don't know what angle that is. That represents a variable and we don't have any value for it right now. So the cosine of 90 degrees, what is x? 0. So that effectively takes care of that. And because those are both cosine of pi over 2, and here we've got the sine, which is positive 1. So we end up with a negative and a positive. So overall we have a negative cosine t over sine t. And of course this is a quotient identity, which is equivalent to cotangent of t. So there it is. We've shown it step by step. Sum and difference formulas. Let's see what else I've got coming up for us in this session. Not much else. You do have some homework to do in class 2 through 6. We'll see how far we can get with this. I want to keep this lesson short. I've had a few long ones, so I'm trying to be good to you, give you some short ones as well. Verify this one. X plus 90 degrees equals cosine x. So we're just going to work with this side and see if we can get it to look like that. I'm just going to pick up the sine sum or difference here, because I think that's all I need, at least for this first one. Put it down here. So I'm going to use the sum, which will be sine of my first angle, x, times cosine of 90 degrees, plus, right, for sine, a sum is the plus of my products, cosine of x, times sine of 90 degrees. Now sine of 90 degrees is 1 and cosine of 90 degrees is 0. So this zeroes out. This becomes just cosine x. Done. Now I really should have shown that this was 0 and shown that this was 1. So I guess I'm not modeling things too well. Make sure you show every step. How about verifying tangent? Well, we haven't even done a single tangent one, so let me grab these, pull them over, so we'll have them for reference. I'll put them right down here. I didn't even bother to stop and see which one we really want. Okay, we're going to want to use the sum one. Okay. So again, I'm going to work with the more complicated side. And we'll use this. The numerator, this is a more complicated identity, isn't it? The numerator is going to be the tangent of alpha plus the tangent of beta. My alpha is x plus the tangent of 180 degrees divided by, and now we're going to have 1 minus the product of those two. So I'm going to have to know what the tangent of 180 degrees is. At 180, my x is -1 and my y is 0. Tangent, its definition, tangent theta, is y over x. So tangent of 180 degrees is 0 over -1, which is equal to 0. So this is going to be tangent x plus 0, and this is going to be 1 minus tangent x times 0. So 0 there will make that term disappear, and we won't bother writing 0, and our answer will be tangent x. Check. These are the sum and difference identities. In class, we'll be doing problems 2 through 6. See you there.